consider the file system, the operating system design as a puzzle, so far we discussed a few key parts of the puzzle. Okay? For example, the first part was how the processes run in operating system, and second part was how does the memory management work to support running of those processes. And now we'll start discussing this last part of the puzzle, the file system. Okay. For many of us, in fact, the file system is the most visible part controlled by the operating system. For example, the first thing that you see when you log into your computer is basically the desktop, and which is essentially a bunch of folders and files on this desktop, on the screen. And for most users, this file system, which is basically considering all these folders and files and different types of files, is the most visible aspect directly controlled by the operating system. So what is file system? Very briefly, it is a mechanism to access the storage. So it is the operating system mechanism to access the storage, or more specifically, the persistent storage, like your hard disk or USB drive or floppy drive or CD-ROM or whatever persistent storage that you can think of. I think like any other other lectures, please write your questions whenever you have them, and stop me when you have doubts. Okay. So the file system has two distinct parts. Okay. And they are a collection of files, which is basically a way to store related data, like a text file will contain this text data, or a file like a .exe file, or it will contain binary executable data, and so on. So so at the second part, how does these files are organized, that is the second part. So the first part of a file system is basically these files, and the second part is a directory structure which organizes and provides information about these files. Like it actually gives the user a way to access these files. So there are two primary parts of this lecture, of this part of file system. First, we'll talk about understanding the file system interface that is provided, or that needs to be provided by every operating system to its users. And the second part, we'll see how this interface is implemented. Think like in this lecture, we'll talk about, or not in only this lecture, this and possibly the next lecture also, we'll primarily talk about that as an operating system developer, what kind of interfaces do you want to make open for this file system? For example, the interfaces might actually mean the open function call that you all used in C or in Python, or then you have function read and write, all those function calls. So what are the interfaces for directories and files that we'll discuss in this part? And the second part, we'll discuss how to implement it. What are the algorithms of implementing it? So this is mostly design. So in the design, what would we learn? So we will start with the basics of file systems. We will discuss what file actually is, right? I mean, we all possibly have some sort of mental model, some sort of like thinking model about these files, how we feel about files, but we'll talk about what file actually is and the access methods of files. We'll also talk about the major disk and directory structures. Then we'll check the semantics of this. How does this file system mounting work, right? I mean, you have this mount command in Linux, or so how does it work? Basically, what do you mean by mounting technically? And then if we have time, we'll talk about file sharing across computers, and also a little bit about the security that the file system provides. Security means, for example, like Srihas's file cannot be accessed by Siba. So that is generally enabled and enforced by file system. So we'll possibly like to talk a little bit about that too, if the time permits. So let's start then, starting from file, the concept of file. So what is a file, right? So file you can think of as a named collection of related information or even smallest arrangement of logical secondary usage. But what does it mean? So the thing is that a computer, right, can store the information in various persistent storage. It can be your hard disk, SSD. It can be, you can even write to CD or DVD, or some of you might actually even use our floppy drives if you want to go for more historical taste. Now the operating system, like when you're writing an operating system, you cannot really, write a code or cannot provide a particular interface for hard drive, another for SSD, another for floppy drive to the user. It needs to be uniform for storing information. And that is what the file does. The operating system abstracts the physical properties of the storage devices and define a logical storage unit. And this logical storage unit is the file. I have given you a 1 terabyte hard disk. You will create multiple files in it. I'll give you a 2 GB SSD based thumb drive. You will create read and write files and files on it. So essentially, file is something that a user program can use without worrying about whether it is an SSD, and hard disk, floppy, CD, nothing. Everything is file. So these files are essentially an abstraction that OS provides to application on their persistent storage devices. And these files, then you can possibly understand that you have to give all the users some sort of way, uniform way to access information, and you call it files. So because it is for the users or for the applications, there has to be a name of the file, because otherwise how would you differentiate one type of information with another? For example, you are saving something like all of your contact information, the phone numbers and names in one place, and you are storing your OS course materials in another place. How can you differentiate without names? So from a user's perspective, uh, a file is basically a named collection of related information, and it is the smallest allotment of logical secondary storage. What does logical here means? Meaning that it doesn't matter what the physical storage is. It might be HDD, hard drive, or SSD or anything. Sorry. But essentially, you can store the information only in files. So in the corollary is data cannot be written to physical drives unless it is in within a file. So what type of data files? So any questions so far about what does file mean? The 15 seconds timer has started. Okay. Please write your questions or doubts in the chat. So, but let's move on. So essentially files is the smallest allotment of logical secondary storage. Great. And it has a name. Again, great. So what type of data does files consider? What type of files are there? So the data files, like the data based on the data that you're writing to the files, it can be like numeric, alphabetic, alphanumeric, or even binary data, right? So it can be numeric or character data, a mix of it, like alphanumeric, both the characters and yeah, sure. So Rachel, I am just going to talk about that next, but I just wanted to know whether you understood what file actually meant before jumping into it. So yeah, we're just going for the different file types and we will be discussing them. So essentially, this is the type, that is the date. The type of the file will depend on the data that you put into it. It might be just a character data. It might be only numeric data, or it can be a mix of them, alphanumeric data. It can be also binary data, right? Now, these are basically data files, not program files. Think of it something like a data that your Python code will read. So these files, uh, these files might be totally unstructured, the data files, for example, text files, or it might be formatted really rigidly. For example, if you look into binary files, like these are super interesting. So in binary files, you would actually feel like audio file is one example of a binary file, and they're super rigid in terms of the structure. In fact, there is a comment called file, right? So you can actually do file space the file name, and it will basically give you the type of the file and the data that it contains. Does it contain binary data? Does it contain specific formatted data? Does it contain non-formatted data? So when you are opening up a text file and taking notes, it's basically unstructured data. It doesn't really have a structure. But when you are listening in your computer in a VLC player some sort of music, it's basically like the audio file is very structured because the VLC needs to be able to read it. And then aside from data files, you have the program files, which are also very important. So data files are for storing different types of data. And we talked about this in the binary data, you have structured and unstructured. And even in the text data, like these data files might be structured and unstructured. Example of structured data is a random text file that you are going to write random text in it, your notepad, if you may, in Windows. And the for closely formatted binary file would be, or structured binary file would be your audio file. Now let's come into the source files. So what is a source file or the program file? It's basically a sequence of subroutines and functions, each of which is further organized by declarations followed by executable statements, right? So you have your functions, definitions, you have the variable declaration, you have the whole logic written here as executable statements, if else block and all the loops and anything that you can think of. Now, remember that when you are using your editor, right? If you're using, say, a Visual Basic, or if you are using VI with syntax on, it basically, correctly highlight the syntax of these files, right? So, any idea that how does it check the type of the file? Say in the program file, say when you're opening a C file and a Python file, your editor often just, if you do a syntax highlighting on, most of the modern editors or code editors basically make the highlights on. How do they know that which code is running there? Mm-hmm. Mm-hmm. Perfect. Yes, extension. That is true. So what does extension mean? We'll come into that later. But the point is here is that in the files shebangs on Unix and extension on Windows, that is even better. So yes, all of you are correct. So essentially, the file looks into not the file, sorry, the program, the editor looks into the file name. And the file name, by general popular choice, has these two parts. The first part is the name of the file, and then dot and the type of the file. But you see, I can write some type of the file as docx, whereas when it is executable, .exe. So that is what you do when you try to fool someone running your own code there. So this extension mentioned in the file name is the way that a code your editor knows what type of program file it is, or even what type of file it is. However, this is not often this is the user's way of telling whatever file this is, or the application's way of telling whatever file this is, and this is not foolproof, meaning that I can have a docx file, I can have an exe file, I can name it docx, and I can send it to a user who would possibly click on it with the hope of opening it in Word. So the program files are identified, or even the data files, the type of data files are often identified for the applications or for the users by their extensions. However, if you look into the file command, it uses some more structured information to actually find it. It cannot differentiate between text files. So your C and Python file looks same to possibly file, not in the modern version, but in the original version. But it can definitely differentiate between the structured files like the audio file and the video file. So it can definitely tell you what is using MP4, not only extension, but which one is using MP4 compression algorithm and which one is using .mp3 or WFV compression. For Rachel's answer, like shebangs or news, actually look into shebangs, all of you. That is, if you don't know this. So essentially, shebang is one line in the file, at the first line of the file, where again the user defines that which program should be used to run that code. So essentially, the shebang is a way, again, for the user to tell the application which is going to run that code or load that code that, look, this Python file, this C file, and so on. But essentially, knowing the type of file is utmost important for you as a user and as the application who is going to run it. Now, this content, the file, is defined by the file's creators, and we talked about different types of files. So contents meaning that whatever you are going to put in the file is definitely defined by you. Correct? Right? That's obvious. But the thing is that you can, I mean, each of this is each of them actually have a structure that you need to follow. What do you mean by structure? If it's a text file, it's unstructured. A source file, essentially, it has a structure. It needs to be it has to be a typical C program, like something that GCC can read, can parse. Otherwise, your parser will fail. Right? In a source file, if it is Python, if there is some syntax is wrong, then your Python interpreter will fail. So it needs to have this specific, some files need to have specific structure. On the other hand, this object file and executable file. So these are two special types of files in general. And any idea that what is the difference between an object file and an executable file? These are all created by us, like the developers, right? But they're different. Any idea how? Just wild guess. All of them have possibilities in the object file. You can also think of in Windows like the DLL files, the shared link libraries, and object file can be in Unix would be .so files. So any idea how they are different from executable files? Okay. So object file, so Ramnivas told that object file has machine language instructions. Sure. Executable file is a binary file, so it might not have machine language instructions. Okay. So it needs to be linked. Yes, Mukul, you're getting there. So object file needs to be linked to deal with external functions. Good. And what about executable files? Do they not need to be linked? Libstart main section. Yes, it does. Yes. So object file also have an entry point, but yeah, but not main. A link to form exe files. Yes, absolutely correct. So Soumitra has this conceptually, it's correct. So all of you are correct, if partially, but still all of you are correct. So essentially object file supports different executions. It is shared amongst different programs. That's absolutely correct. But when what Mukul actually told, which is true. So from a file part of view, right? So object file is a sequence of bytes again, which is organized into blocks understandable by the system's linker. It needs to be linked to different other processes, other executables to provide them external functions. That is all of your .so files that you are downloading. Like if you ever, if you ever looked into .so in your Linux or .dll from your Windows, they are all shared libraries. They provide various functionalities to various codes, and that's why they need to be linked, right? Because there has to be a way to link those files, this .so files, to your code, so that you can just call that dot functionalities of that so file and get done with some functionalities. On the other hand, for an executable file is a series of code sections that the loader can bring into the memory and execute. So the object file needs to be linked, executable file needs to be loaded. Understood? Any questions there? So all of you are correct. As this actually, like, object file has machine learning instruction. Yes, it does, right? I mean, because object files needs to provide functionalities. This is like libraries, shared libraries for to your program, to Mukul's program, Shubham's program, everyone else's program. So yes, they have machine language instructions, but they need to be linked. And executable is also it needs to be loaded by a loader. And this loader and linker, they're provided by the system. You don't need to worry about it. And in executable, when Shubham told we have a libc start main section, what does it mean? Meaning the loader needs to know where to start executing, which part. Meaning that your object file needs to be such that the linker can read, execute it, link it to other files, share it with other programs. Executable needs to be in a structure where the loader can read it, for example, having a main start section. So essentially, the the yeah. The bottom line is this: a file often has a structure that is a sequence of, for example, a sequence of characters. Like if you open an audio file, you would actually cannot read it, but it is hex data. But if you look into first few bytes, okay, at the beginning, the first few ones, they're they're same for the same types of audio files. The header information, if you may, is same. So essentially, a file often has a particular structure. It can be a sequence of characters. It can be a specific bits at the beginning. It can be specific bits at the end. It can have a particular section. It can have a particular macro, a particular word in some particular place. But it often has a structure. For all the useful files, has a structure. Now, you see, these files are not really created by, like, by the operating system developers, except for what the executable file type would be, and possibly the object file type would be, because they are fundamental in running the system's loader and linker. However, you can yourself create file structures, and people do that. By people, I mean that, for example, when you look into MS Word, Microsoft Word, it has doc.doc, .docx, .pptx, .ppt. They're not created by any operating system developers. They are created by the Microsoft developers. Similarly, you have in JPEG, JPG, MP4, and there are like so many different types of files, image files even, or audio files, or video files. In fact, during 10 years back, or 10 years back almost, like it was sort of a fashion to come up with better compression algorithms for video files uh, in every 2 years. We got MP4, WAV, MKV. Uh, I don't even recall this, all these different WAFF and a bunch of them. The point is that you can create your own file. You just need to define the structure, and then you need to write a code which can read that structure and do useful things. For example, playing music or showing you video. But sometimes it might backfire. So this is, for example, Adobe being a big company and having a great product like Adobe Photoshop is already are basically like crossing the threshold of creating their own file type, and they did it. Yeah, they created their own file type. So that doesn't really always go well. So this is like a rant pointed out. This is from a GitHub, right? And I also put this like from the Z Photoshop loader.m in the github.com kjk /z repository. And let me read this out for pure fun. But it just says like when you are designing file formats which other people will use, you need to be a bit careful. So this poor developer was trying to read the PSD files created by Adobe to do something useful. For example, opening it up for editing. And the comment goes like, at this point, I would like to take a moment to speak to you about the Adobe PSD format. PSD is not a good format. PSD is not even a bad format. Calling it such would be an insult to other bad formats, such as PCX or JPEG. No, PSD is an abysmal format. Having worked on this code for several weeks now, my hate for PSD has grown to a raging fire that burns with the fierce passion of a million suns. If there are two different ways of doing something, PSD will do both in different places. What do you mean by, now, just a comment, what do you mean two different ways of doing something? Basically, if you want to set a flag that your image file is editable or non-editable, then PSD will do both in different places, and you possibly need to figure out that in both places you need to put a check box. It will then make up 3 more ways to say no sane human mind would think of and do those two. PSD makes inconsistency an art form. Why? For instance, read silently decide, and after that it is like in sometimes PSD is writing data in chunks of 4 KB, sometimes in 2 KB without any reasoning. So essentially, you can define your own file type in your own file name, but when you do that, this will better be structured and consistent. And just creating a file type is not enough. Essentially, you need to also create it in a structured way so that a code can read it and do useful functions, or can execute useful functions on it. Okay, so now we know what is file, which is basically this logical unit of that the user can read or write. And we also thought about that. We moved on and talked about how the files can have different extensions. It can have different types of data, and it often is structured, the useful ones. And you can create your own file structure. All you have to do is basically to actually give the header file correctly, meaning that you need to actually put some unique binary data or character at the beginning of it. You need to then define the mechanism, the different sections of your file, what will go in and out, so that a program can read it. Now let's look into, because we talked about file type. Essentially, file consists the types, the file types that it has, and we also talked about object executable file, something every system would have essentially, because every system has libraries and processes. Let's move into the names of the files, or essentially the file attributes in general. But let's start with names. So a file is named for the convenience of its human users, and a file is referred to by only its name. So what is a name? A name is usually a string of characters. For example, notes.txt. And some operating systems differentiate between uppercase and lowercase characters in names, whereas other systems do not. Some OS put a limit on the number of characters on the names. Actually, every OS puts it. By the way, have you ever hit a character limit in the file names in Windows or in Linux? So that actually means it is extremely large. Yeah, you did. Awesome. So, what is the limit that you found? Good. Nice. Yep, that is correct. 256 characters on Linux, fairly big, but not exactly impossible when you are working intensely on this type of thing systems for long. So essentially, operating system do you think that it is differentiate between uppercase and lowercase letters? Like this file names, like if you could name a file notes.txt and then in small letters and capital letters, capital notes.txt, would Linux mind? And in Windows? Linux does, Windows, Mac OS doesn't. Mukul is absolutely correct. Ramnivas, you are correct. Rashul, you are correct too. So essentially, all of these are systems parameters that someone set and told like, look, this is what it is and deal with it. But the point is that they all provide these names of the files. Windows has a special flag to set sensitivity. You mean the sensitivity of file names, Rashid? Okay. Case sensitivity, yes. Yep. So unset by default. So essentially, and most users will use defaults. But yeah, Linux actually differentiates between cases. So you can create more files in Linux. Windows, macOS by default does not, but you can patch or basically you can unset the flags to actually do it. But that is even more work. Most users don't know about. So when a file is named, right, like whatever convention that your operating system basically provided, it becomes actually independent of the process that creates that files. In fact, it becomes independent of user and even of the system. And that is how you can upload your assignment one underscore roll number one dot zip to Moodle. We can download it and we can evaluate it. So when you name a file, it becomes independent of the process, the user, and even the systems that created it. And even if you created your file on Windows for developing, I'm going to run on my Mac or on my Linux, Ubuntu, and it will work most of the times. But the point is that naming a file makes it independent of systems. Now, aside from names, right? Aside from this name, which is set by the operating system, but generally can be sent to any other systems, like from the created system. There are other attributes also, right? And these attributes actually vary from one operating system to another, but typically consists of, aside from name, an identifier, which is a unique number that identifies file within that file system. Then there is type of file. For example, there is it's a text file, a C file, a Python file, and it also has the location of the file. But that is where the actual file data is on the disk. Because ultimately, when you are asking OS that play this song or open this C file, open the Pintos directory and the C file within that, the operating system needs to know that which part on the device, basically means the hard disk, is the data, because only from there they can read it. only from the location they can read the data. So it needs to create this file attribute needs to have the exact location also. And essentially, there is also there is also most operating systems stores the size of the file and who can read the file, write the file, execute the file. That also has some protection information associated with it. The OS also have the time and date and who created this. So these are general. These are because these are operating system design class, right? If you're designing an operating system, even for a firmware, like for an IoT device, these are the things that generally you associate with a file. This will go. This generally helps you in doing multiple tasks in the future with the file. Now, the information like this time, date, who can access, protection just means that who can access this, who can read the file, who can write the file, who can execute the file. So all of this information, they're kept in a directory structure, which also resides on your hard disk or your secondary storage. Or it can be your SSD, of course, or flash drive or pen drive. So what does it typically, what is a directory entry? What are you talking about directory structure here, which is, interesting. So essentially this is like a directory entry is basically a file's name and the unique identifier, these two. These two will go in the directory structure. Okay. And this identifier can be used to retrieve the other file attributes. Now, the problem is that, or if not the problem, so directory is something like a phone directory. So a phone directory, what does it have? I don't know whether you guys use phone directories or looking up, but you definitely use Google for looking up phone numbers, right? And if you have seen phone directories, and I don't know how many of you have seen phone directories. I am not. I don't believe most of you, but the thing is that in a phone directory you have a names and numbers, names for the person and numbers to you have Ramnivas. Great. Okay. So telephone directories has a huge dictionary like books which has these names and numbers. Yes, YOLO books, pretty much. I actually used to have YOLO books in Germany every year till at least 2007, 16-ish. They have advertisements and they have names and numbers. So what you're interested here is that this directory structure is just a reminiscence, like when it was written, telephone directories are at their peaks. That's why the name directory came in. Okay, telephone directory. That's what I mean. It's funny, but it is what it is. And in telephone directory, you have the names and phone numbers. Here you have names and file numbers, the identifiers, unique number that identifies files within the whole file system. And the rest of them, once you know the identifier, you can actually bring back all of this information. So there are, we talked about this basic file attributes, but there are many more. For example, extended file attributes like the file checksum to know if the file is corrupted or not. Very useful, specifically in this environment where your hard disk runs the risk of getting corrupted, making the file system corrupted, or even many of you possibly have seen that you cannot open a file, and then you actually run some code or some program which basically checks the file and say like this is corrupted and you need to fix the directory structure. So you need to know if the file contents, what does corruption mean? The file contents are modified in such a way it is not readable anymore. It doesn't follow the structure anymore. So some actually include external file attributes, something called file checksum, which checks whether the file contents are okay or does the structure change? Did the structure change? Okay. So this data, like this whole directory structure and all the files, they are non-volatile. So directories are stored in the device and brought into memory as needed, because this also means that, so you know all about memory, right? So you know that if something is in SSD, you need to bring back to the memory for execution and so on and so forth. So everything here, like this directory structure, the file's information, the size of the file, the location of the file, who can do reading, writing, executing, knowing that and enforcing it, everything is done in the main memory, but the information is in the hard drive. Meaning that when you execute a code which is using a file, you need to bring back this information into main memory from this non-volatile memory to volatile memory, and then you need to uh, process that information. I'll give you a very small example before moving on from here. So say you wanted to know that whether Rachel is able to run a particular code. You means you are the operating system developer and you want to know if Rachel should be able to run a particular code that he is trying to run, or open a particular file that he is trying to open. So first, you need to look into the file name. From file name, you go to the directory structure. You bring the directory structure to main memory. You read it. You look into the identifier. From the name, you go to identifier. From identifier, that's basically just an index. Think of it more like an array of files, and it's just an index in the array of the files, the file table. Array of the file in the file table. And from that array, you go to that place. Again on the secondary storage, you fetch the protection, basically who can do reading, writing, and executing. And then you check the people who can execute whether Rachel's name is in there. After that if else statement, you basically either grant Rachel permission or you don't. So file attributes and files. And so files with their attributes as well as the directory structure resides on the secondary storage, which needs to be bring to the primary storage, main memory, RAM, whatever name it is, you like to call it, and then it will be processed. So how to know these file attributes? Why I'm asking how to know? Because sometimes as a developer, you want to know for a file, how to know more about the file than that which is just given by the name. Okay. So you can use the stat command here. So if you do there's this comments like stat notes.txt. File will tell you the date, the second slide or third slide. Basically, file will tell you this command. File will tell you the type of file. Stat will tell you all the attributes, and ls-l will give you the summary of the attributes. So if you do stat, I'm just showing an example here. It says like file notes.txt, size 39, number of blocks 2, IO block. This is block number like 1048576 regular file, and this is basically 2 power something 20, I guess. The device, it's basically the device name. inode will come, this is very important letter. And then it basically says like access, there's the protection thing here. And so basically who can access, who created this, and who can read, write, or execute. So 0644 is write or execute. If time permits, we'll get back here. But essentially what I'm trying to say is that all these attributes that we talked about here, name, identifier type, location, size, protection, time, date, user identification, you can check that, like whatever attributes the Linux store using stat. Okay. Remember these attributes. Why do you need to remember this attribute? Simply because that if you want to design an operating system tomorrow, again, for an IoT device that you are creating, you are the startup entrepreneur and you need to create this special file type for your special IoT device. You need to know that what does that file should, like in your firmware, what information do you want to store? And for that, at least this information, name, you need to support the name, identifier, that will be a file table, and you will basically have to store the index of that file, particular file in the file table, the type, location, size, type of the files, location of the file, size of the file, who can access it, time, date in that file. Okay, so I would actually, if you have not ever used stat or file, I'm just going to ask you to please do it now. open up a terminal and go and do stat and try to actually understand. In the with file actually have really some funny, interesting file types embedded in it. So you can use files on random files, and you can actually check what does the file command gives you. What are the file types that is inferred by this file? By the way, do you know, like I have seen at least some work which basically uses machine learning to know file type, because sometimes people don't really name their files properly. But the problem with machine learning is that it's slow. So there is a lot of hacks and a lot of systems, say heuristics to make it better. But essentially, even knowing the type of file is or is not a solved problem, but something that people saturate, saying like, don't open random file types. But there is still active work going on with it. Okay, so file, for each one of them designing this, like let's actually recap once. So file, we talked about file system interface. We talked about what is file. And then we talked about that what type of data does file have and what type of structure does file have. Then we talked about the attributes that each file has. And we finally talked about how to check those attributes of each file in a file system. Now, we will end it here after giving you this basic idea, and we'll go into the file operations in the next class. So essentially, a file is just an abstract data type, and it's basically, again, a logical unit where the user will write their data, perhaps in a structured way. Structured way meaning in the first few lines, this particular binary information will go in, then there will be a block of text, then there will be a block of binary data, something like follows a structure. But again, it's an abstract notion, abstract data type, like a stack or a queue. So we define a file properly. Sure. So I have, so Rashil asked, like from the perspective of file system itself, all text and source files are identical. Yes. So from the perspective of file system itself, all text and source files are identical, but all object and executable files are identical. We seem to be differentiating them on the basis of how they are used, not what they are. So I would say that not quite. So we are differential. You are correct that we are they are all following a similar interface for reading or writing, or the operations performed on them are same. In fact, this particular slide of file operations shows the unified file operations that can be used on these files. And we are differentiating these files based on, we are differentiating these files based on the type of data they have, which is, you are correct, that how they are used or what is the application of it. But at the end of the day, if your so your file system provides an abstraction to store data and load that data. You are absolutely correct about that. But a file generally becomes useful when you consider on how these files are used. Because if you have unstructured data, then people means even the developers, like the operating system, basically told that we are like, you have to write your own application to read that data or load that data. We are not going to support it. So from the perspective of file system, storage of file, all the data, all text and source files are identical. They are a bunch of data, a bunch of bits and bytes. You are correct. However, if you want to make files useful, then you need to differentiate based on their applications and how they are handled by which applications. So that is my response to your comment, that you are right, but you should not play down the importance of how to use a file while creating a file system, while creating these files. And the operating system needs to support these attributes of files by itself, which is common for all the files. But aside from, so just moving on here, aside from attributes, the file needs to also have operations like create, write, read, seek, delete, and truncate. And we'll go over them, each one of them next class. This class is already over. But you see, this 1, 2, 3, 4, 5, 6, these 6 operations are supposed to be these operations which are fundamental. Apparently, all the things that you can do in an operating system or provides, all the functionalities that an operating system provides can be derived from the 6. And we'll discuss, actually, we'll discuss in the from the next class that why that is so, meaning that what does each of them, each of these operations signify and how you can implement others using them. So thanks a lot for joining. We'll continue this from the next class on Wednesday. Thank you. So if you have any other question or if you want to stay back and discuss, please feel free to do so in the next 5 minutes or feel free to leave. Okay. So I'm stopping the recording.